Assalamualaikum. My name is Sufyan and I am in 7th semester data science. And in this presentation, I will talk about an important topic which is ensuring data privacy and security in autonomous vehicles within smart city environment. So let's first talk about what are these two terms: autonomous vehicles and smart city environment. Autonomous vehicles are self-driving cars that do not require any driver to operate. They use cameras, sensors, and artificial intelligence to make decisions, navigate roads, avoid obstacles, and they can follow the traffic rules on their own. Smart city environment is a system that uses sensors in cities, data, and the internet to control and improve how city works. It controls several things, including its water management, energy efficiency, waste management, public safety, and traffic monitoring and traffic management, etc. So this study proposes the combination of three cutting-edge technologies which are federated learning, blockchain, and reinforcement learning. And this integration aims to provide data security and privacy in autonomous vehicles within smart cities. So let's talk about the agenda. What are we going to cover today? First of all, methodology of research paper, how this research was conducted, key components of BFRL framework, data collection and pre-processing, the challenges we faced and how we will address them in future, and lastly conclusion. So let's begin the video by diving into the methodology. The methodology of this research focuses on proposing a technological framework to address data privacy and security challenges in autonomous vehicles (ACVs) within smart cities. So the literature review was conducted a systematic review of existing research, and we narrowed down to 82 articles into 101 articles by choosing keywords, searching techniques, using different filters, and lastly declaring an inclusion and exclusion criteria. The keywords we chose were data privacy, data security, autonomous vehicles, and smart cities. The techniques that were used were Boolean and or not operation, etc. And filters we only picked those researches that were conducted between year 2014 to 2024. And the inclusion and exclusion criteria was that we only included those research papers that were related to data privacy security framework with relative to ACVs, and we discarded those studies that were not related to ACVs and were only theoretical studies instead of empirical data. So you can see how much research papers were selected each year from 2014 to 2024. There are three key components of BFRL framework which are federated learning, reinforcement learning, and blockchain. Federated learning allows vehicle to train their model locally by using their own data without sharing the raw data on its central servers, and it uses privacy preservation techniques for security measures. And reinforcement learning allows a vehicle to make decisions adopting the dynamic environment. It uses the feedback mechanism. It gets the positive feedback when it does something which it is supposed to do, and when it is do something that it is not supposed to do, means a wrong decision, then it gets the negative feedback. So it improves on those feedbacks, and it tries to avoid the negative feedback, and it makes right decisions. Blockchain ensures the secure communication from vehicles to their central servers and central servers to the vehicles. We usually use blockchain to share the updates from central server to the autonomous vehicles. The data was collected using the real-time sensors of the vehicles, their traffic condition, and communication network. And that data was pre-processed locally in the vehicles to extract relevant features to train the models further. But the challenges that were arise were missing data and imbalanced data set that we addressed by using different techniques like augmentation and data segmentation. BFRL framework works on several layers which are local data processing, model updates via blockchain, global model aggregation, and continuous learning. Local data processing is that vehicle train models on their own data locally, and the data is processed locally without sharing it on central servers. Model updates are shared from central server to the vehicles using blockchain for secure communication, and secure data transportation and in encrypted form. Model the updates of model are aggregated using secure techniques like homomorphic encryption on central servers, and the updates are combined using secure methods like homomorphic encryption in central servers, and they are then shared from central server to the vehicles. And continuous learning means the system evolves with the data, ensuring the adaptability to dynamic urban conditions. Despite this progress, we face some challenges that were balancing data privacy with model accuracy, ensuring scalability and interoperability across the system, protecting against adversarial attacks. To address these challenges, we can take these steps in the future, which are developing energy efficient and scalable protocols, establishing interoperability standards for seamless collaboration, and lastly, integrating more sophisticated AI models to improve performance under dynamic conditions. These efforts aim to make autonomous systems safer and more reliable in smart city environments. In conclusion, the combination of these three technologies, blockchain, federated learning, and reinforcement learning, and combining them into what we call blockchain-enabled federated reinforcement learning or BFRL framework, it provides data privacy and security. Not only it provides data privacy and security, it also ensures it also supports the development of efficient, adaptive, smart transportation system. And that was all from my side. Thank you for your attention. And if you have any question, then you can ask in the comments.